Hello there, hope everyone is doing well and staying safe. In this video, we will be going over one of the main foundations in DevOps, build pipelines. So let's get started. Before we get deeper into build pipelines, first let's get a bit more familiar with what a pipeline is in software development. So what is a pipeline? Is it similar to its physical version? Well, sort of. A software pipeline has the same concept as its physical version, where any action that is executed is in a one-directional sequential order. What I mean by this is, let's say we have three processes: process A, process B, and process C. We start our process execution at A as it's the starting point for the pipeline sequence. Once process A's execution is over, its output will be directly used as an input for process B. Once process B's execution is over, process C will then use process B's output as an input, and so forth. Once process C's execution is completed, the result of the process will then be presented by finalizing the chain of events, creating a software pipeline. For example, let's say we are going to do some laundry. In our laundry room, we have a washer, a dryer, and two laundry baskets. These baskets are labeled as an input laundry basket and a final basket. We first start by inserting our dirty clothes into the washer from the input laundry basket, making the input laundry basket empty. Once the washer's process is done, we take out the clothes and directly place them into the dryer. Once the dryer's process is done, we then take out the clothes and place them into a final laundry basket ready for the next step. Now that we have an understanding of what a pipeline is in software development, let's take a look at what a build pipeline is. So what is a build pipeline? Well, the build pipeline's concept is similar to its software pipeline version. However, there are two main differences that make the build pipelines unique. The first difference is in the execution style of the pipeline. In a build pipeline, an output from a process will not be directly inserted into the next process. Instead, the outputs are usually located in the environments the build processes are being executed in, allowing processes from A's output to go to a specific location in the build environment to be only ingested as the next or future task's input. What I mean by this is, let's say we have our three processes again, process A, process B, and process C. But this time, we also have a location where our process's output will be placed after their completion. We start our process's execution at A as usual, as it's the starting point for the build pipeline sequence. Once process A's execution is over, its output will be placed into the build output location to be used as an input for process B. Once process B's execution is over, process C will then use process B's output from the output location as an input, and so forth. Once process C's execution is completed, the result of the final process will then be presented, finalizing the chain of events, creating a build pipeline. For example, let's say we are going to do some laundry again, but this time in our laundry room we have a washer, a dryer, and three laundry baskets. These baskets are labeled as an input laundry basket, an output basket, and a final basket. We first start by inserting our dirty clothes into the washer from the input laundry basket, making the input laundry basket empty. Once the washer is done, we place the clothes into the output laundry basket to dry a little. Afterwards, we grab the clothes from the output laundry basket to insert it into our dryer. Once the dryer is done, we then place our clothes into the final basket for delivery. The other difference is the artifact creation at the end of the pipeline process. At the end of each build pipeline, when a build has been successfully completed, an artifact gets produced ready to move on to the next step in the software release lifecycle. If we were to reference our previous laundry example, just imagine the clothes in the final basket folded and the whole basket is packed in a cardboard box ready to be delivered for the next step. Or, if we were to reference our process build pipeline example, process C's output as the final process in the build pipeline sequence will be the final output that will be packaged and published, creating an artifact. Well, you might be wondering, well, that's great, but I'm still not sure what an artifact is. So, what is an artifact? Well, artifacts are compiled source code that has been passed through some sort of build automation. In our case, that would be the build pipeline. They are usually in a .zip or compressed format for network transfer or build to release pipeline transfer. They allow the build and release processes to be streamlined in the software development cycle, making the whole infrastructure to be automated. One note I would like to make is that the artifact creation has to be compiled automatically in a build environment. Otherwise, it will be referenced as a compiled code and nothing more. Additionally, the artifact definition in build and release pipeline is different from an artifact definition in overall software development. For example, an artifact by its software development definition can be anything that's produced during the software development phase, and the pipeline's artifact is by definition a code that is automatically compiled for testing or the release pipelines. As a final note, the build pipeline doesn't need to be triggered automatically. It can be started manually if needed. The starting of the build pipeline, whether automatically by trigger or manually by a command, does not define its overall concept. The automation within the build pipeline and the artifact the build pipeline produces is what it makes is what it is, and not how it starts. However, the processes inside the build pipeline should be executed in an automatic fashion, as is one of its core principles of creating a build pipeline. Usually you don't have to worry about this, as almost all build pipeline services have this fully automatic. Before we wrap our video, let us take a look at a simple build pipeline example where we build a .NET 5 application utilizing Azure DevOps as our platform, allowing us to get a better understanding on how a build pipeline might look like in a real build scenario. Before we go into build steps, we first have to select the software application the build pipelines will be executed with, allowing us to utilize the software application's default capabilities. Next, we select the code that will be pulled down with a specific branch into a build environment location, where software that is part of the build environment either has knowledge of it or has access to that location, allowing any processes that request to use that location will be able to. For the final preparation step, we create demands for the build pipeline software to have, allowing us to make sure the build environment's software has the required build tools we need. Now, as the first build step, we start out by setting up the application requirements such as installing .NET Core SDKs and the NuGet package installer to make sure we have everything the application needs. After we have the build environment location and its software that will be used to build our application, we move on to restoring any NuGet packages that's needed for the application to be compiled properly. Next, we can finally build the application utilizing MS-Build and MS-Build's argument parameters to fully control the build process. After we have the application fully compiled, we then compress our compiled code to be published as an artifact. And finally, we publish our compressed code as an artifact, completing our build pipeline process. In conclusion, to define a build pipeline, you should keep a couple concepts in mind. 1. Build pipelines are similar to software pipelines, but not identical. They have two unique properties, an output location and an artifact publication, where software pipelines ingest output directly as an input to further the pipeline's process. 2. Build pipelines' internal building process should be automatic, but they aren't defined or limited to being triggered automatically. As long as they are internally automatically executing the build process, the build pipeline definition still stands. 3. Build pipelines require for an artifact to be published for the next steps in the software development lifecycle, while software pipelines do not. Thank you for watching. If you have any questions on database concepts, DevOps, or anything computer science related, feel free to post them down below. If you like this video and would like to see more, please don't forget to subscribe. See you next time.